Hello, welcome to another edition of Cracking the Cryptic. We've done a few slightly off-kilter videos the last few days, so hopefully you've all had a chance now to watch the video we did on the hardest puzzle we've ever seen, which was the, about adventure, a puzzle that appeared in the Galactic Puzzle Hunt. We've also got the video coming out on Mark's attempt on the 1965 Times crossword that appeared online the other day. But I'm going to stick to what we've been doing a lot of, which is sort of standard Sudoku, Killer Sudoku Times crosswords. We're going to take a look at this deadly rated Killer Sudoku that appeared in the Times yesterday. I'm going to do this slightly different style to normal though. I'm not going to talk through absolutely everything that I'm doing. So you can see the grid here on the screen. And what I'm going to do is I'm going to pause the video now and just fill in some really obvious things, like this 24 box I can immediately see has to be 7, 8, 9, this 4 cell has to be 1, 3, this 16 has to be 7, 9, that has to be 8, 9. So there's a whole series of things I can immediately spot. And then we'll just focus on the sort of key logical steps to finding the solution this week. So I'll be highlighting squares and saying, you know, can you spot what this number is? More of a sort of Q&A type approach. And immediately, as I was just filling in these obvious ones, I can see this grid pattern is going to be very susceptible to geometry, I guess. I mean, we can write in the value of this cell. So again, think about how to do that. Don't have to use geometry to that, just have to know some simple rules about what can form part of cages, especially this cage here, this 8 cage. Obviously this can be 1, 2, 5 or 1, 3, 4. Whichever option it is, it contains a 1. Therefore this cannot contain a 1. Let's just fill that in quickly. The fact that the 3 now appears in here means this must be 1, 2, 5. Some order, let's write that in. You can see now this 24 cage has to contain a 4, but that's not going to be terribly helpful. And we can write in the value of this digit and this digit now. So again, pause if you need to think about how to do that. The reason we can write the value of this digit is that we know that if I draw an imaginary line down the grid like this, every number, once we have a complete solution, the numbers 1 to 9 will appear in each column, each of these 4 columns, exactly once each. So we know that we'll have, as the numbers 1 to 9 add up to 45, every number to the right of this imaginary line will add up to 180, i.e. 45 times 4. Now you can see that there are lots and lots of cages entirely contained to the right of this line, and in fact the only cage that sort of sticks out is this 7 cage. So if we add up all of the cages to the right of this imaginary line, we'll get the difference between 180 and this cell, or once we subtract that total from 180, we'll get the value of this cell. Now, somebody posted a good comment about how to do this, because of course you can do it and just add up all the numbers, but you can actually do this more quickly by just focusing on the units digit, because you know that the eventual sum of all these cages will be a number between 171 and 179, because this number has to be a number from 1 to 9. Now, if that's the case, we only actually have to add the unit digits here up, because the result, let's say we add the unit digits up and we come up with a 4, we know actually that will be the number 174 had we added up all of the 10s as well. So a little trick there. So I mean, I'll actually illustrate it here. 6 plus 9, so that's obviously 15, but we can just cancel that down to 5. Similarly, 2, 0, 0, 8, 4, 4, 8, 5, 7. So this has to be a 3. We just have to make sure the total adds up to 10 in effect. That's a 3, and that's a 4. And then we can do a similar type trick on the bottom 2 rows of the grid. Again, the bottom 2 rows will add to 90 in total. And that means we can isolate the value of these 2 cells and in turn these 2 cells. And I'd be surprised if, given some of the restrictions we already have in columns 1 and 2, if that prevents us from actually being able to almost fill this box. So let's just do that. We've got 4, 19, 38, 50, 64, 81. So we know these 2 add up to 9, and therefore these 2 have to add to 15. Now we know this box contains a 6. We know one of these 3 cells has to be a 6, because there has to be a 6 somewhere in column 1. Now if the 6 was part of the 9, i.e. part of these 2 cells, this would be a 3, so that's not possible. So in fact, we can now write 6 and 9 in here, like so, and that means that these 2 cells have to be 4 and 5, because we know there has to be a 4 in column 1. Oops, other way around. That's the 4, and that's the 5 there. This therefore has to be a 9. We can remove the 9 from these 2 positions. We're starting to make a little bit of progress. Now the next thing I use is a little trick we can do on this 9 cage here. Now you can note that there's a 4 and a 3 in these 2 positions, but this 4 and 3 are really powerful in relation to this 9 cage, because actually they prevent a 4 or a 3 being anywhere in this 9 cage. You can see obviously they stop these 2 cells being 4 and 3, but also this cell can't be a 4 or 3 either. And it doesn't take much mental or checking to think, well obviously we can make a 9 with 6, 1, 2, but any other combination will use either a 4 or a 3. So this has to be 6, 1, 2 in some combination. We should certainly write that in. We can see, looking at row 1, we have a 20 cage and a 16 cage entirely contained within row 1 already, so those 2 cages sum to 36. Therefore the outside cells, these 2 cells, have to sum up to 9 in order to ensure that the row sums to 45. If this is 7 or an 8, this can only be 1 or 2. Similar trick on column 9 here. I mean, there's a few things we could note about column 9, but perhaps the most obvious is that these 5 cells here sum to 35. Therefore these 4 cells sum to 10. Now the only way that you can make 10 in 4 cells is if they are exactly the numbers 1, 2, 3 and 4. Well look, we already have a 3 and a 4 here, therefore this cell has to be 1 or a 2. That's beautiful now, because these 2 cells have to be 3 and 4, and therefore this cell has to be a 1. These 2 cells have to sum to 16, therefore they have to be 7 and 9, and there's a 9 here. So this has to be 7, this has to be 9, this has to be 7, and this has to be 8. In fact, this has to be 5, because we have a triple of 1, 2 and 6 in these 3 cells. Therefore this cell must be 5. These 3 cells now sum to 22. That means they must include a 9. The only place a 9 could go would be here. And the other 2 cells will have to be 6 and 7, because the 5, 8 is ruled out because of this 5 here. So 6, 7 can only go this way round. This isn't a 6. Yeah, and we're really starting to make quite good progress now. Remembering these 2 outside cells have to sum to 9, this now has to be a 2, this has to be a 1, this has to be a 1. Therefore we've got 2 and 6 in some order in these 2 positions. And 3, 4, 8 in these 2 positions. This now is very limited, this cell. We know one of these 2 cells has to be an 8, therefore the other 2 have to add up to 8 as well. Well, we can't therefore include 4 in that, because otherwise we'd have 2 4s. So this is 3, 8, this is 4, this is 3, this is 5. Okay. do some more notation. This has got to be 567, 567, like that. Oops. Remove the 1 from this position and this position. Therefore, there's only one place a 1 can go in this 8 box now. And this 20 has to be 1469, which is, look, we have a 1 and a 4 in this cage already, therefore this has to be 1, 4 in some order, these two cells here, but there's already a 1 here, so in fact this has to be a 1, this has to be a 4, 6, 9 into these two cells, which means this has to be a 2, this has to be a 6. So we're left with 2, 3, 5 into these positions here. Let's just write those in. Let's call it 5. This has to be 8. And we can do some arithmetic now on column 2. So these two cells sum to 6, plus 9 is 15, plus 4 and 9 here is 28. So we know these three cells have to sum up to 17. Now if these three cells sum to 17, then in order for this 20 cage to work, this will have to be a 3. Now if this is a 3, this has to be a 2. And therefore we can complete all of these cells like that. Now these have to be 7 and 8 because 6 and 9 isn't possible because of this 9 here. I'm pretty sure the puzzle's almost solved now. This now has to be 3, 6, which has to be in a particular order because of this 3. Oops, 6. It's going to be a 6 therefore. That's a 9. This is a 9. This is a 7. 4, 5 in some order. Oops. Which means these two cells have to sum to 14. Still can't quite rule out one of the. Oh, yes, we can. Yes, 5, 5, 9 isn't possible because of the 5 here. So this has to be 6, 8. Which allows us to write in a 6 and a 9 up at the top there. This has to be 2, 8 in some order. Obviously this can't be a 2, it's going to have to be the 8. Resolves this 17 cage down here. And again we can do the same sort of trick now on row 9. So we have 24, 28 plus 12 is 40, therefore this cell has to be a 5 in order to ensure that the row adds up to 45. I'm tempted now to look immediately at the central column because of this 19 cage. So this 19 plus this 5 is 24, plus these two cells is 34. Therefore these two cells here have to sum to 11. Now the only possibility left for that is 2, 9 because 3 8's ruled out by this 8, 4, 7 by this 4, and 5, 6 by either this 5 or this 6. So this is 2 and 9 in some order, and look, we have a 2 here already. So that's a 2, and that's a 9. And therefore this is a 3, isn't it, I think, in order to make that cage work. 1, 2, 3. So these two cells are 4 and 5. We can't quite see in which order yet. Let's make a note of it. And there's numerous ways to finish off from here. The puzzle is solved effectively. It's simply a matter of filling in the remaining digits as quickly as you can and as efficiently as you can in order to record a good time. Let's remove the 5s from here. This has to be a 7. This has to be a 6. That resolves this 6 and 8 combination, which resolves this 8 and 7 combination. Okay. So we're looking now along here, this has to be a 4 or a 5. Therefore this has to be a 7. These two cells sum to 15. This has to be 1 and 3, therefore. Only way that works is in that orientation. This now has to be 4, 5, 4, like that. 2 and 9 into these positions. Only works if it's that way round. It's got to be a 6. This has to be 2, 4. Annoyingly can't resolve that immediately. Let's put that in like that. This is 1, 3. Can only be one way round, which is like this. This has to be 12. Has to be 4, 8. Again, annoyingly we can't quite resolve which way round that's going to work. But this 3 here resolves everything. That's got to be 3. That's got to be 8. 8, 4, 4, 2, 2, 5 in these positions, and that's how you solve the deadly Killer Sudoku. Thanks for watching.